Hello, algebra students. This is about take 75. I'm just having a fit of trouble here with my new computer. And it's just, I posted a video last night, and Angela Demchuk said, "Hey, Mr. Lawrence, there's no sound." Ah! Okay, so having some problems, but let's get down to it. Enough of my complaining. Today we're going to be solving systems of linear equations by graphing. Now, before we do that, before we find out what it means to solve a system, let's remember that slope-intercept form could look like y equals mx plus b, or it could look like y equals b plus mx, or they could even be negatives, y equals mx minus b, right? Or y equals b minus mx, or both the terms could be negative. As long as the y is alone, we're in slope-intercept form. When the y is alone for a linear equation, we know that the number in front of x, the coefficient of x, the m value, is the slope, the movement. And we know that the number added or subtracted to x is the y-intercept, okay? So we start by graphing the y-intercept and then rising and running using the slope. Okay, now standard form. Standard form looks like ax plus by equals c, and remember, the a must be positive, okay? And when we have standard form, we find a, b, and c. We can find the slope by doing the negative of a over b, and then we can set up a table to find either the x-intercept or the y-intercept. Remember, to find an intercept, we make the opposite coordinate 0. So if we're looking for the x-intercept, we make y 0, plug it in, solve for x. And if we're looking for the y-intercept, we make x 0, substitute 0 in for x, solve for y. Okay? Now we don't need all three of those. We only need two of them. We can graph with just the two intercepts. We can graph with the y-intercept and the slope. We can graph with the x-intercept and the slope. All right. So what does it mean to solve a system? Well, before I tell you, let's go ahead and graph this red equation. It's in slope-intercept form because y is alone. The y-intercept is at 0, 4, because the 4 is just sitting here by itself. So 1, 2, 3, 4. Okay. And then our slope is negative 1/3. So from that y-intercept, which I should have labeled, I'm going to go down 1, right 1, 2, 3. I'm going to rise negative 1, run 1, 2, 3. Okay. I'm going to go back 1, go up 1, and then left 1, 2, 3. Remember, I can change both signs. I can do that, or I can do this. They're all the same fraction. Okay, so let me get this line down. And 1, 2, 3. Looks like I'm off a little bit. Let me make him a little thinner and give him an arrowhead, and then I'll adjust them. I want to hit those points as accurately as possible. So that should be it. Okay. Now, before we graph the green one or talk about what a system is, can you solve the red equation, the y equals negative 1/3 x plus 4? Can you solve that? And the answer is no. You don't know how to solve one equation with two variables. The line shows us that there are an infinite number of solutions. I was going to say millions, but that's not even enough. It's way more than millions. If we were to make a table, and I'm not going to make a very long one, but I'll give you the point here, I could plug as many values in for x as I want, and I'm going to get many different things out for y. So they're all going to be different. So for example, when x is 0, y is 4. When x is 3, y is 3. I'm just substituting it in. Negative 3 is going to give me 5. And you see, excuse me, this is going to go on forever and ever and ever. The line shows us all possible solutions to the linear equation. But when we have a system, it means we have two or more lines. And so what we're looking for is if these lines intersect each other. If they do, that's going to be the solution to our system. So let's go down to this green equation and see if we can't solve it, solve this system, that is. It's in standard form, so I'm doing A, B, C. Easy, that's 2, -3, -21. Okay, and the slope of this is going to be -2 over -3, which is 2/3, right? Now I'm going to go find one of the intercepts. I don't need them, find them both. So many of you just automatically want to find the y-intercept. It's okay if it works, but it doesn't always work. Sometimes you get a real ugly number. In this case, the y-intercept is going to be the friendlier one. I can tell by looking at C and seeing either if A or B goes in evenly to C. If it does, that's the intercept I want to find. I know that -3 goes into 21. B is attached to y, so I'm going to find the y-intercept. So let me see here. I'm going to take 2 times 0 minus 3y equals -21. And that will turn to 0. I'm going to get -3y equals -21. And dividing by -3 on both sides, y is going to equal 7. So my y-intercept is going to occur at 0, 7, which I believe is right there. Now, my slope is 2/3, but I'm out of room, so I'm going to use the -2 over -3 for my slope. We'll go down 2 and back 1, 2, 3. Oh, look at that. These lines are going to cross right at that point. 2, 1, 2, 3. I'm going to finish drawing my line, and I will know the solution. My line's going to go right like that. I always have to get an arrowhead on here, like so. And my solution occurs right here at this point. So the solution to this system is the point -3, and then 1, 2, 3, 4, 5, 5. That is the solution to this system. So to find a solution to a system of equations means to find out where they intersect. All right, let's try this one. Looks like both equations are in standard form. So I'll do the red one first. A, B, C. Easy as 6, -4, 12. And my slope is going to be the negative of 6 over -4, which is going to be 3 over 2. Now, do I want to find the x-intercept or the y-intercept? Looks like it's my choice because A divides into C evenly and B divides into C evenly. So I'm going to find the x-intercept just because so many of you only go for the y-intercept, okay? So I'm going to find the x-intercept first in this case. So I'm going to make y 0. So I'm going to get 6x minus 4 times 0 equals 12. All right, that's going to cancel. 6x is going to equal 12. Going to divide by 6, divide by 6. X is going to equal 2. So 2, 0 is a point on the graph. It's the x-intercept right there, 2, 0. Now, I'm going to find the y-intercept, but I'm not going to use it, okay? Just want to make a point here. So I put 0 in for x, and when I do, I'm going to get -3 out. Okay, watch what's going to happen with the graph. All right, so my slope is 3 over 2, so I'm going to rise 1, 2, 3, run 1, 2. And I can go down 1, 2, 3, and back 1, 2. Look at that. Where did I hit the y-axis? At -3. And that's what I said I was going to do. Just showing you, you don't need all 3 pieces of information to graph. You only need 2 of them. Okay, so let me send this line on a diet here. And give them an arrowhead at the start. And that looks pretty good. Okay, so let's go to the other line. And let me see here. I need to do A, B, and C. So A, B, C. Easy as 3, 3, 6. Okay, so my slope is going to be negative 3 over 3, which is negative 1 over 1. And which intercept do you want to find this time? Well, I found the y-intercept last time, excuse me, the x-intercept. So I guess I'll go find the y-intercept because both of them go into C evenly, both A and B. So I'll go ahead and find the y-intercept. And so I'm going to do 3 times 0 plus 3y equals 6. And I'll bet a lot of you can tell me y is going to be 2. That cancels. 3y equals 6. Y is going to equal 2. How did I do that? I divided both sides by 3. Okay, so the y-intercept is 2. And my slope is negative 1 over 1, so I go down 1, right 1, down 1, right 1. Look at that. They're going to intersect at the x-intercept. And that's a little bit of a tongue twister. They're going to intersect at the x-intercept. Okay, and so there is my other equation. My solution is actually the x-intercept. Now, they don't have to cross at a pretty place. I'm giving you examples where they do, but they don't have to, and this form of solving is somewhat limited because they don't have to cross at a pretty intersection. All right, so let's see here. Notice I've got x and y and the origin labeled on all of my graphs. I have it on the last one. Let's go check. Sure did. Okay, so here I'm going to do the green one first because the red one some of you are going to get wrong. So let's do the green one first. Let's go. It's in standard form. A, B, C. Easy as 2, 4, 6. So my slope is going to be negative 2 over 4, which is negative 1/2. I'm going to find an intercept. Now, I'm going to cheat. I'm going to look and see. Does A go into C evenly? Absolutely. Does B go into C evenly? Not evenly. So I'm going to find the x-intercept. So I'm going to make y 0. All right. So I'm going to get 2x plus 4 times 0 equals 6. That'll cancel. I'll get 2x equals 6. And so x is going to equal 3. All right, x is going to be 3. So my x-intercept is at 3, 0. Okay, now my slope is going to be negative 1/2. So I'm going to go down 1, right 2. Down 1, right 2. And I can go up 1, left 2. Up 1, left 2. And remember what I said about the y-intercept not going, B not going into C evenly? You can see I didn't hit a point on the y-axis when I graphed. If you were to go ahead and check, find the y-intercept, you'd come up with 1 1/2. And if you look and see where my line is crossing the y-axis, it is crossing pretty close to 1 1/2. It's hard to be exactly correct. Okay, looks like it might be off a little bit, but then it could just be human error in the graphing. That looks a little bit better. Okay, so now the red one's actually the easier line to graph if you realize y is alone, therefore you're in slope-intercept form. How many x's are in the equation? Don't say none. I haven't let you say none as an answer all year. 0. There are 0 x's in the equation. So the y-intercept is at negative 2. Okay, and the slope is 0 over 1. So I'll rise 0, run 1. Rise 0, run 1, rise 0, run 1. Looks like I'm going to get a horizontal line. And so I get a horizontal line going through negative 2. That looks like it might be off a smidgen. It's not going to let me do it. Oh, there it is. Okay, properties. Make them a little bit thinner. We'll make them orange. It's very close to being red. And there you go. So what's the solution to this equation? Well, the solution is occurring at 7, negative 2. Right there. Okay. Number 4. Again, I'm going to do the green one first because it's in standard form. A, B, C. Easy as for negative 5, negative 16. And the slope is going to be negative 4 over negative 5, which is 4/5. All right, go looking for intercepts, and I check. I notice that B doesn't go into C evenly, but A does. So I'm going to find the x-intercept again. And so I'm going to go 4x minus 5 times 0, just substituting 0 in for y, equals negative 16. This is going to cancel, yielding the equation 4x equals negative 16 divided by 4 divided by 4. X is going to equal negative 4. Okay, x equaled negative 4, and put in my labels on my graph. And so my x-intercept is here, negative 4. My slope is 4/5, so 1, 2, 3, 4, 1, 2, 3, 4, 5, and 4, 1, 2, 3, 4, 5 right there. So I get a nice line going like this, okay? 2, 3, 4, 2, 3, 4, 5. I don't know if you notice, I often do that because the more points I have plotted, the easier it is for me to actually graph it. Okay. You only need 2 points to make the graph, but to make it as accurate as possible, I put more points on. All right, now the red equation. This one's easy too. Believe it or not, it's in standard form. Yeah, it's like 1x. Excuse me, don't do that. Sorry. Okay. It's like 1x. See the 1? Plus, how many y's are there? 0 y's equals 6. So I can do A, B, C. Easy as 1, 0, 6. Now, when I go to find my slope, I'm going to get negative 1 over 0. When I go to find an intercept, an interesting thing happens. If you try to find the y-intercept by plugging 0 in for x, watch what's going to happen. You're going to get 0y equals 6, right? Because this is going to cancel. And dividing by 0. Are you ever allowed to divide by 0? No. And I know it looks like we're dividing by 0. There we are. This equation actually has no slope. Doesn't mean we can't graph it. It just has no slope. So I can't find the y-intercept. You know why? There isn't one. Yeah, there is no y-intercept. This line will not cross the y-axis. So let's go find the x-intercept. Put 0 in for y, which it's already there. So I'm going to get x equals 6. If I divide by 1, which is really a complete waste of time, right? Because x equals 6 is what I get. Then the x-intercept is at 6, 0. So let's go 6, 0. Now, let's use that slope even though it is undefined. Let's go down 1, right, run 0. Down negative 1, run 0. Down 1, run 0. Looks like I'm getting a vertical line. And wouldn't this vertical line be parallel to the y-axis? And since they're parallel, they'll never cross. So there is a solution to this system. The solution is this point right here, which looks like it'll be the point 6, 8. Okay? By the way, you see x equals 6? That's not a coincidence. Not a coincidence at all. All right. So sometimes a system won't have a solution, or it could have an infinite number of solutions. Okay? If two lines end up being parallel, we'll say there are no solutions. No solutions, because they'll never intersect. If two lines end up being the same exact line, we'll say there's an infinite number of solutions because they cross everywhere. You're thinking, wait a minute, how can that happen? All right, well, let's graph this red one. It's in slope-intercept form. Y-intercept is 8. And I'm going to go down 1, 2, 3, 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. And we're going to graph this. Let me make it a little bit longer. Okay. All right, now the green one. Uh, Standard form. And so I'm going to do A, B, C, E, yes, 6, 8, 64. And then we're going to do, the slope is going to be negative 6 over 8, which is negative 3/4. Okay. And you notice I'm getting the same slope as I did in the other one. That's a hint that's an indication that these lines are not going to cross if they have the same slope, or that they will end up being the same line. One of the two things will happen since the slopes are the same. Either they'll be parallel or they'll end up being the same line. In this case, I'm going to find one of the intercepts. I notice that B does go into C evenly, so I'm going to find the y-intercept. And so I'm going to get 6 times 0 plus 8y equals 64. And when I do that, I get 8y equals 64. Dividing by 8 yields y equals 8. So my y-intercept is 8. Well, look at that. I have the same y-intercept and the same slope. These are the same exact line. Therefore, there is an infinite number of solutions. An infinite number of solutions to this equation. And the way I show it is I usually put a second set of arrowheads, but I want you to see what it's actually going to look like. Oop, I'm on the wrong line. There we go. Yeah, I can even make it thin like that. And then you can see that they're actually touching everywhere. Okay, every single point on either line is a point on the other line, and therefore there's an infinite number of solutions. There is an infinite number of solutions to this system, number 5, okay? Had the y-intercepts been different with the same slopes, they would have had no solution because the two lines would have been parallel. All right, hopefully this take works. I apologize for the length, but we're not trying to bog you down, just trying to show you how to solve a system of linear equations. That's it for today's video. Mr. Laurence signing off. Have a good night, everybody.